So, hello and welcome. This is a basic video about setting up a CheapFocer 2 with the vesc tool. This project specifically is about a Funwheel, and there have been a lot of questions on the Discord channel, so I wanted to take you through what I do to set it up and get the wheel going. So first connect everything, the hall sensors, the phase wires, battery, USB, connect it all, and then open the vesc tool. Upper right corner, connect to the vesc tool, and it should say connected to your COM port. First thing that I do is I just use the basic wizard to set up the motor, so I have a starting point. So let's do that. The wheel that we are using for the Funwheel is a big ass hub wheel. It's a 10-inch wheel from Fungineers website. Cool guy, by the way. Thank you for everything. So we use the large inrunner. Hit next. Yeps. I use a 12S battery pack with 8 amp hours of capacity. Hit next. Set it to direct drive because we don't use any pulleys, and set your wheel diameter. In my case it's 227. Then run detection with no can, of course. The wheel is gonna spin, so make sure everything is clear and no cables are in the way. So let's do that. Yes, it's going to spin. Okay. Here we go. Zip. Yeah, maybe you hear it or not, but it's now turning back and forth with some high-pitched noise. Completely normal. Wait until it's finished. And then you should have something like this. Fog detection result, success. This is important. See that your hall sensors are recognized. If it isn't the case, this is going to say sensorless. Please check your connections, because most of you guys are using doesn't use the crimp tool for GST, so it's not perfectly connected, so make sure the connections are perfect. So finish. Then what I do is I go to my general motor settings to set my current. What I'm gonna do here is just for basic bench testing. If we leave it at these values, the wheel is gonna spin like crazy and we're gonna hit max duty cycle in a flip of a second. So we're gonna enter 5 amps just to bench test. This is a gentle setting, so your wheel doesn't go very crazy. My battery can handle 70 amps, and I will leave this at 60, no problem. The voltage. What I do with the tip of Mitch, the developer of the Balance app, is the cutoff start. We set it at 0, and I will leave the cutoff end at 36 volts. It's to save my battery pack if I don't listen to the tilt back saying your battery is almost empty. If I hit 36 volts, the motor will shut off and I will probably smack on my face, but it's to prevent the battery going up in smoke. So if that's okay, here you can see 3 things. This is to read motor values, read the default motor values, and write. We're gonna hit write, so these are saved to the vesc. Okay, so we head over to FOC, these are your values the motor has detected. If you do the detection manually, you can do a disorder and these bars will become green. You can forget it for now. If you're like me and you want to see it green anyways, you can do this order of arrows and then apply it. I just wanted to show you guys this. The Hall sensor page. If you get a sensorless detection, you can always try it here again to see if the wizard maybe made a mistake or something, or the Hall sensors are really not okay. Just press the play hit. I can do that. The motor is going to spin slowly. It's going to detect the Hall sensors and you will get new values here in the table. So with it spinning back and forth, push, voila, all result received, apply, and you get the values here and here. Save the motor settings. Okay, so this is all for the motor wizard. The motor current max is for now for bench testing absolutely necessary. Do not forget it. Later change it back if you're going to write to your max motor current set, what your motor can handle, because with 5 amps it won't transport a human, I guess. Next, the app settings, general, or the IMU. Maybe we should start first with IMU. Press here on the right side and click these 3 green, so you get real-time data. And if you move your fucker, you will see that the gyro is reacting, which is very good. Set the filter to Mahoney. Save it. These 3 are for the app settings. Save it already, so you get better values. If you can see, here is where I applied the Mahoney filter and my roll went slowly up to 0. Go to general, app to use UARTs. We want the balance app, and you can see NRF changed to balance. Here is where you can see everything to change, to go forth and back with the Funwheel. If we apply this now, if we save this, then the wheel is going to start already. So you can do that. We can see our gyro is exactly at 0, so normally the wheel shouldn't spin. If we write, and I move this a tiny bit, check here down under, you can see the duty cycle and the current used. Don't mind my ADC values because I don't have my pull down resistors yet. I started with a new fucker because my previous one got up in smoke, unfortunately, but it's good for this video. If you get pull down resistors, these 2 values will be set at 0. So normally if I move my nothing. Okay, so what am I doing wrong? Let me check. I'm gonna change these values to the values I got from the developer of the balance app. You should really check his video, super useful. These are now all gentle settings, I presume. Tilt back angle 8. Duty cycle 75. Leave it on 75, max 80. Don't go any further because you won't have any headroom left to get tilt back. The low voltage tilt back should be set to, for me, 38 or 40 volts. Maybe I should use 38 for now because my battery is at 40 volts. If you hit this, you will get a signal from the board that your battery is almost empty. That's what I said before here with the voltage in the motor settings. It will cut off at 36, and now you will get a warning at 38 volts. The PIDs is something you should do when you're riding. You should check it and gently increase it. Normally you will end up around 8, 9, 10 here on the P, and on the D something between 150 and 200. No use for I, don't bother. So we're gonna, yes, I know, we're gonna use a very small P value and then the motor will start. So if you save this, the motor will start, and as you see I should calibrate the IMU because the pitch is at 1 something something. Then you will see the duty cycle, it will go up and then it will cut off because it will hit 75. I'm gonna save. Still nothing. Oh, there we go. So now the wheel is going back and forth. I'm just holding my my fucker in my hand. Oh, take it easy. I don't mind it. It's my wheel is standing on very loose carton boxes. And as you see, going backwards, going forwards, going backwards, going forwards. So this is something you should start with slowly. And as you see, if I go to 75, it will shut itself off. Voila. When you hit the max duty cycle in your bench test, you need to rewrite the app settings because you will cause the dead state set here. If you do not want to do that, you can set this to 1 and then the duty cycle cutoff won't happen. You can keep on going. So that's it for here. This is, some people use 20 here to keep you more balanced. But for now, I don't know, I haven't ridden my board yet, so I will leave it at 2, what the Balance app developer said. Really shout out to him because he did a freaking amazing job. Use small values, set the P to 1, ride it and try it in your hand, but very gently. Here the ADCs, if they're set at 0 for your foot pressure sensor, then it won't react. You see, value is on, state is dead. If I set this at 1 volt, allez, I ride it. Shouldn't be 1 volt, it should be 2 volts. Well, then the value is set to off. If I press the sensor, if I had one, and it goes above 2 volts, then it will go on, and then it will start balancing. So for now, this is it for now. If you get any questions, send it to me on Discord, in Fungineers server. Really cool people there. I hope you learned something, and yeah, see you later. Bye.